Friend, in this video we are going to learn the secrets of the schematic diagram, like how to use schematic diagram, what are the techniques, and power sequence. So in this first video we are going to learn the power sequence, how the power sequence works. So here is my board, and this one is a Dell laptops, and the second page is a basically is a block diagram for the laptop. You can see here the center there is a CPU. The CPU is a Broadwell CPU, and the Broadwell, that means that this CPU is a fifth generation. And here are some components. All the components are connected to the CPU. Like here is a SIO. As in the schematic diagram, there is a name. SIO is not mentioned. There is a mention is a KBC or the EC. KBC stand for the keyboard controller, or the EC stand for the embedded controller. So here is a KBC and SIO, and the number of this SIO is a NPC 285, that is a Newton SIO, and this information is on page number 24. And here is a flash ROM. Flash ROM is a BIOS. It is not mentioned the BIOS, this is mentioned the flash ROM. And you can see here this BIOS is connected to the both component. Like this flash ROM is a 8 MB on the page number 25, and it's connected to the SIO also, and it's connected to the CPU also. That means this BIOS is shared to the both. It's connected here and connected here also. Okay, it's like that. Then there are other components like the hard disk, then the optical drives, then the card readers, and the USB 3, then USB 2. Then here is a display EDP, enhanced display port, that is the page number 52. Then the HDMI at page number 54. Then the VG on the page number 55. So these are the different ports are connected to the different uh, component, like the CPU's component to the different. Now we'll go to this side. So this side is a basically a power, where the power, like first here you can see here on the page number, here the written mention the charger. The charger means our A section, that means adapter inputs and battery charging section, and that is on page number 44, our A section. Okay, and the next is on the page number 45. There is a 3.3 volt and 5 volt section. Okay, and the ICs uses a TPS 51225. And the next is CPU core section, page number 46 and 47. Then page number 9, the DDR3L RAM sections 1.35 and 0.67. Then the core 1.05, that is a system voltage for the PCH, that is a 1.05, that is on the page number 48. And this 1.5 voltage again to the CPU, that is on the page number 51. So this all informations are given here. Okay, and what we'll do is we'll just scroll the pages and we'll go to the last page. I'll scroll down and I'll come to the last page, and then we can just go a little up and up and up and up. Now you can see here is a power sequence are given. The power sequence are given here on the two concept. One is called this ladders. These are the ladders, and another is called the sequence. This ladder, first we understand what is a ladder. So you can come here and we can see, so what is a ladder. So ladders means the first thing what you have to do is, so first thing in any laptop, the first thing should be the RTCVCC, that is our CMOS battery, that is a 3 volt should become. Okay, the 3 volt should become, so that is a RTCVCC. And then the next signal is called the RTC reset, that is also 3 volt. Okay, so first is RTC VCC, then the RTC reset, and here is a 3 volt, and here is again the 3 volt. Then here the DC bed out, that is our adapter or the battery output, that is somewhere around, if the adapter only there, then the 19 voltage, and if the battery only there, then the 11.1 volt, and if the both things are there, then the 19 volt. It's like that. Then this 3.3V, that means 3.3 S5 aux underscore S5, that is a S5 voltage. So here, so this is a S5 voltage. Okay, so this S5 voltage, this is a S5 voltage. S5 voltage is a 3.3. So this is a linear voltage. This is a linear voltage VRG3. Okay, so this is a linear voltage. After that, when you press the power button, at that time when we press the power button, the 3 volt goes to 0. It will remain 0 until and unless we release the power button, and once we release the power button, come back to 3. So that the pulse will be generated, and the next this all the signal will be generated one after another. So we have to check from the top. So if my laptop is dead, then you have to check all the signal one after another. So it's like that. Okay. So in this way you have to check all the signal one by one. Now in this side, you can come on this side. On this side, here the numbers are given. Here the numbers are given. Like you can see here, there are so many number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 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 how to go through all this number? So first you have to start from minus. Okay, you have to start from here is my CPU, then here is my SIO, and these are the different buck converters. Okay, so these are the different buck converters. The first thing is here that my input, adapter and battery inputs. So these are the two inputs, battery and the adapter. Here's my adapter voltage will be somewhere around 11.1, and the battery voltage is 11.1 volt, and the adapter voltage will be the 19 voltage. So both volt will go inside, and here the output voltage generate here. Okay, and so this is a step number -7. So you have to check this first. Then the second is -6. So this is a -6. So once this adapter is detected, then this charging IC generate one signal, and that signal is called the ACOK signal. That is a 3 volts. So you have to check that, and this signal is going to the SIO. It's called the AC in signal. Is going to the SIO. Okay, so you have to check the signal at TSL_EN1 pin. Okay, so this is step number 6. Then the step number 5, the DC bat voltage will go inside in the different buck converter, and that voltage is somewhere around 19 volt. And then so this section is a 3 volt and 5 volt section. This section is a 3 volt and 5 volt section. After 5, then the -5, then -4, -5 and -4. Then this VRG3 will be generated. VREG3 will be generated and generate a 3.3 voltage S5 voltage. Okay, and this voltage is going to the SIO. So here is my SIO. Okay, so this 3 voltage is going to the SIO. So this is step number 4. After step number 4, the step number 3, -3, here you have to go like this: -5, -7, -6, -5, -4, and then the -3. As soon as SIO got this power and got the this AC signal and the ECU reset, and if the bias is okay, then SI will generate one more signal. It's called the S5 enable signals, -3 S5 enable signal. Okay, so this signal is going to here, this signal is going to here, this signal is going to here, and it's given enabled to the 3 volt and 5 volt section. So S5 enable, so you have to check the 3 volt here. This 3 volt enable this buck converter 3 volt and 5 volt section, and once it's got the enable signal, then this 3 volt and 5 volt will be generated. That is step number -2. After -3, -2. Okay, and then the -1. Once this both the voltage will be generated, then the SI will generate the next signal is called the RSM RST. SI will generate which signal? RSM RST. This signal will be generated by SIO. So this is a -1. So now all these steps are completed before power on button press. That means from step number -7 to -1, all the signals or the voltages are coming one after another before power button. Now here the SI will stop, is not going to do anything unless and until the power button is pressed. So here after -1, here is a 1, only 1. You can see here is a -1 and only 1, that is a +1. So here is my power button, the KBC power button. It's going to the PSL underscore EN pin on the SIO. So here will be 3 volt, and once we press the power button, it goes to 0 and come back to 3. So that means the 303 pulse will be generated here. So this is step number 1. So once this power button is pressed, this pulse will be generated, and then the SIO will generate the next signal is called this signal, PM power button. This signal, SI will generate PM power button signal. Okay, after 1, then step number 2, PM power button signal will be generated by the SIO. Okay, and then after step number 2, the step number 3 is you can see here, step number 1, step number 2, and then step number 3. Here's the step number 4. Yeah, step number 3. You can see here step number 3. You can see here step number 3. As soon as SIO generate the PM power button, that is the post power button or the digital power button to the Haswell processor, then the Haswell processor generate 2 signal that is called PM underscore SLPS4 and PM underscore SLPS3. These 2 signal are generated like this. So this 2 signal will be generated, and both signal are 3 volt, 3 volt and 3 volt. So this is going to the enable. So first the SLPS4 signal generate this signal generator is given to this RAM buck converter. So this is a RAM buck converter, and the RAM buck converter generate this 3.3, that means 1.35 voltage. Okay, so this is a DDR3L RAM. DDR3L. So DDR3L require a 1.35 voltage, and then the 0.67 voltage. So both voltage will be generated by this section, and then the power good signal will be generated. And after that, SLPS3 signal give enable to this 1.05, that step number 4, and that step after step number 4 there will be a 4A and 4B. 4A, that is a 1.05 voltage, and this voltage is given to the PCH, and the power good will be generated. Okay, so in this way step number 4 and 4B will be generated. Then step number 4B here is called the run power. Okay, so this is a run power. Okay, and here are the switches are there. Here are the switches. So what do you mean by switches? So here are the 3 MOSFETs are used. So here the input voltage is a 5 volt, and then once this got the enable signal, then this 5 volt transfer here, and the input voltage here is a 3 volt. Once got the enable signal from here, then it will generate this 3 volt will be passed to here. So that is a 5 underscore 05 and 3.3 underscore 03, both the voltage will be generated. That is on step number 5. And then once this all the voltages are generated, then the step number 6 is here is the step number 6. Here is the step number 6, and this signal is called PCH power. Okay, okay, this signal is called the PCH power. Okay, the PCH power. Okay, so this signal is called the PCH power. Okay, generated by the SIO, and meaning of this signal is the all powers are okay, that without the CPU all the power like 3.35, 1.05, then 1.35 and 1.5, the all voltages are generated without the CPU core voltage, and this signal is called the PCH power. Okay, and this signal is going to the CPU saying the all powers are okay, now you can turn on the CPU core voltage. The meaning of this signal is like that. So once the CPU got the signal, it's called the PCH power. Okay, then the CPU turn on this core voltage, it's called the VR on signal. Step number 7, it's called the VR enable or the VR on signal. And then at step number 7, when the signal will be generated, after that the core voltage will be generated here, step number 7. And then so this is a CPU core chips. At page number 46, chip uses TPS 51622. Okay, then after 7, then the CPU core at step number 8, the CPU core voltage will be generated, and this voltage is given to the CPU. Okay, and then after 8, then 9 will be the VRM power good. This is called the IMVP power good. Step number 9. Okay, step not voltage. This is not the voltage. Okay, step number 9 is called the IMVP power good. IMVP power good means the CPU core voltage is stable now, and once this signal will be generated, then this signal is going to the CPU saying the system power okay. Now you can see there are two power okay signal. One is called the PCH power okay, and another is called the system power okay. The PCH power okay means the all voltages are generated without the CPU core, and the system power okay signal means the all power are generated with the CPU core. So this is a difference. Okay, so this is a step number 9, and then after the 9, then the next signal is called step number 10. So we'll see where is the step number 10, step number 11, step number 12. Yeah, so here is the step number 12, S0 power good is going to the CPU saying the all powers are okay, and then step number 11 is called SVID signal. SVID signal. So this SVID signal is a communicate with the VRM chips that how much the core voltages is required. So this is called the VID, voltage identification signal, communicate with the VRM chips. And once the voltage is stable, and then at the step number 12, this last signal is generated, is called the PLT reset. PLT reset, platform reset, PLT RST. So this is called the final signal at step number 12. Step number 12. And once this voltage is generated, then the clock will start it and the bias started reading. So in this way, the power sequence take place. Okay. So with the help of this sequence, you can able to find any problem like if the laptop is not turned on, then you can diagnose the problem in the motherboard. Now you will say how to diagnose or how to test this signal and where to test this signal. So simply I'll show you this example. Suppose if you want to test whether this 3.3 volt is coming or not. So for that, what you have to do is what I will do is I will go to the minus this minus 4 steps, and what I'll do is I'll select this signal is called 3.3V aux S5. I'll just copy this signal, then I'll come here and go to the, I'll paste it here, and then I will place a next, 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 and this signal is going to the SIO at pin number 75, and then I'll next, click on next, click on next, next, then next, and next, 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 next. Yeah, I'll stop here. Now you can see the 3.3 underscore aux underscore S5 signal is coming from here. So here is a one small resistor is called the PR4532, and the value of this resistor is 0. 0 means nothing is there, that point is short. So this is a 3.3 volt. This voltage is going to the SIO. This voltage is going to the SIO. Now this voltage is coming from here. So 3.3 underscore power underscore 2. So where this you can see here, these 2 points are same name, 3.3D3V underscore PWR underscore 2, and here is also mentioned the same 3D3V underscore PWR underscore 2. That means the both point are connected. These are the both point are connected to each other. Okay, so that means this voltage is coming from here, and the location of the chip is PU4503 and the chip number is TPS 511225. So this is a 3 volt and 5 volt chips. Okay, and the voltage is going to the chip from the DC bat out, that is from current sensing resistor. This 19 volt going to the chips at pin number 12, and once this is received the voltages, then these chips will generate the two voltages. One is a 3.3 voltage at VRG3, and one is at pin number 13, 5 voltage will be generated. So friend, if this 3 voltage is not coming here, then what you have to do is you have to check this input voltage, and if the input voltage is coming but the output voltage is not coming, in that case this chip is bad, so you have to replace this chip. So simply you have to follow the steps. Okay, so again we'll go to the our next signal. So now we check 3.3 underscore aux underscore S5 signal. Now we'll see one more signal, like a power button signal. So here are the two power button. One is called the input power button, it's called the KVC underscore power button, and another is called the post power button, it's called the PM underscore power button. So these are two power button. So this power button is an input power button. The user press Once the user press this power button, at that time the 303 pulse will be generated, and this signal is going to the CPU. Okay, and then this chips, once we press this power button, step number one, then the step number two should be generate PM underscore power button, and here also the 303 pulse should be generated. Now if you want to check this signal, then what we have to do is we have to same thing, we have to copy this signal, and we have to come here, paste it here, and go to the next, go to the next, go to the next, go to the, now here is my CPU. So this is the power button input to the CPU. You can see here the how you identify whether it is CPU. So you can see the pin number like AK2, AC3. These are the BGA CPU, and here also the mention SHW, HSW. Okay, as well. Okay, and this information is coming from page number 24. Okay, so we'll go to the next. Okay, we are here at page number 24. So this is the page number 24. Then I will zoom, and you can see this information is coming from pin number 117. So here is a SIO, and number of this SIO is a NPC 285, and this signal generated by the SIO at pin number 117. So what I have to do is I have to connect my multimeter at here at pin number 117, and once I press the power button, there should be the 303 pulse should be generated, and if this 303 pulse will not generate, then the SIO is not responding properly. Then in that case either SIO is bad or my EC bias is bad. Here in this model the EC bias and main bias is a combined, so in that case we have to flash first main bias. If problem is not solved, then we have to replace the SIO. So friend, in this way we have to trace the signal. So now we'll go to the next signal. Okay, so now the power button is there. The next signal we are going to check that SLPS4. Okay, we'll check this SLPS4, step number 3. So where to check this signal? Simple, come here, select this, copy it, paste it here, click on the next, 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 next. Here is the CPU, so you can't check signal here, so click on the next, check, same the CPU is there, go click on the next, wait, stop. So here is my SIO, NPC 285. So here is my SIO, and the pin number is 21. Pin number is 21. So I have to check the signal at pin number 21. 3 volts supposed to come here at this point. Now if this 3 volt is not coming here, that means the CPU is not responding properly. CPU is not emitting this signal PM underscore SLP underscore S4, and the S5 also you can check obviously. And if this voltage is not coming, then CPU may not getting the power, VCC DSW may not be coming, or RTC VCC not coming. So you have to check all this previous signal, all the previous signal, whether why these signals are not coming. So in this way you have to follow this steps, and and you can follow this chart, and you can follow this steps also. You can start from RTC VCC, RTC reset, DC bad out, then you are to 3.3, and this mode is a DC mode. DC mode means when you are checking the power from the battery, and this mode is called the AC mode. The AC mode, when you check the power from the adapter, at that time you have to follow this ladder. So this is called the ladder. So you have simply you start checking the signal from the RTC VCC first, then the RTC reset 3 volt, VCC DSW. VCC DSW is basically the power to the PCH, then DPWR okay, DPWR okay, again the confirmation signal to the PCH that the power is stable, then the battery low signal should be the high, SLP SUS signal should be the high, VCC SUS signal, then the RSM RST. So you have to start from the top. You have to start from the top. All the signals are 3 volt, 3 volt, 3 volt. So here is a 0 volt, 3 volt, 3 volt. And if you find one of the signal is remained at 0, then you have to go back and check why that signal is 0. You have to follow the sequence like that. Okay. So I hope you understand this secrets of the schematic diagram of the Wistron motherboard.